everyone, this video is about factors, past paper 3 questions. For example, number 1, two lines of equations r equals this, r equals that, in alpha and mu, where a is a constant. Given that the two lines intersect, find a. Okay, so we have the first line 1 2 1, so ijk 1 2 1 plus lambda times a2 minus 1 equals 2 1 minus 1 plus mu times 2 minus 1 1. We form the equation from the x components 1 plus a lambda equals 2 plus 2 mu, and the second y component 2 plus 2 lambda 1 plus minus mu 1 minus lambda equals minus 1 plus mu. And now from the last two equations we can maybe rearrange 2 lambda plus u. You move minus u to the left, we get plus u. You move 2 to the right, you get minus 2. 1 minus 2 is minus 1. And we have minus lambda minus mu equals minus 2. You just add and you get lambda equals minus 3. And from this equation you can plug in the lambda, which is minus 3. So minus 3 minus mu equals minus 2. This is plus 3. Move to the right, minus 3 minus 2 minus 3 minus 5. So the mu is 5. And we use the first equation here. We plug in the mu equals 5 and the lambda equals minus 3. We get an equation only in a. So minus 3a equals 11. So a equals minus 11 over 3. So we have found the value of a, and to find the position factor we can find the point using the first equation 1 2 1. The lambda, we know the lambda is minus 3, so you replace the lambda with minus 3, or you can use the second equation, replace the mu with 5, and you will get exactly the same. Using any of the line equations here, you will get exactly the same point, 12 minus 4 4. Given instead that the acute angle between the two lines is inverse cos 1 over 6. Okay, so the formula is this from the MF19. After you rearrange, theta equals inverse cos the dot product divided by the product of the magnitudes. The factor a is a2 minus 1. We are using the line direction only, so we are using the one with the lambda and the mu. a2 minus 1, 2 minus 1 1, and we get a2 minus 1, 2 minus 1 1. For the magnitude we use the square root of a squared. 2 squared is 4 minus 1 squared is 1. 4 1 1. And for the dot product, a times 2, 2 times minus 1 times 1. And now we can kind of like cross multiply. So here we have 5 plus a squared, and here we have 6. So square root this times square root 6 times 1, which is just this, and 6 times this is 2a minus 3. So you have 6 times something. Yeah, we can divide by 6, we get 1. Divide by 6, we get 6. So we have just a squared plus 5 on the left. On the right, 6 times 4, 6 times minus 12, 6 times 9. You expand and move everything to the right. So 24 minus 1 and 54 minus 5. And we use the quadratic formula, minus b plus minus square root b squared minus 4ac all over 2a, and you get the value of a. We have two values actually, so we have two possible values. Alright, next we have a quadrilateral ABCD, a trapezium, ABDC parallel. We know the A point B, we know the ABC. Given that DC equals 3AB, find D. Okay, so I suggest you to draw like a sketch the ABCD trapezium. Write down what you know. You know the A, you know the B, you know the C. So the factor AB from A to B, of course, there'll be 2 1 minus 2. And because DC equals 3AB, of course the factor CD or DC is 3 times this. CD is minus 3 times this, so minus 6 minus 3 plus 6. This is the factor CD from C to D. So the rule for from C to D is minus 6 minus 3 minus 6, plus 6. So 2 minus 6 we get minus 4, 2 minus 3 we get minus 1, minus 3 minus plus 6 we get 3. So that's how we can find the coordinates of D. And for B, state a factor equation for the line through A and B. So the factor equation, for the factor equation we need a point on the line and the direction. So we know that the point A is on this line and the direction is this direction AB. So just put the factor for A here and the factor for AB here. That's it, we get the line equation. Find the distance between the parallel sides. So this is complicated. And find the area. Okay, so since they are parallel, we need to find like the height, right, to find the area. So let's just draw like this additional point E. Let's say the coordinates are x, y, z. Now CE times AB, direction of CE, direction of AB, if you multiply you should get 0 because they are perpendicular. So what is CE? CE is E minus C. So x minus 2, y minus 2, z minus minus 3, so z plus 3. The AB is 2 minus 1 minus 2. So you multiply x minus 2 times 2, y minus 2 times 1, z plus 3 times minus 2, we get this. And they have to be 0. So if you simplify, 2x plus y minus 2z equals, this is minus 12, move to the right, plus 12. And from the line equation here, because this E is on the line through A and B, of course the point E satisfies this equation. So the x can be replaced with a minus 1 plus 2 lambda and so on. So x becomes minus 1 plus 2 lambda, the y becomes 2 plus lambda, the z becomes 3 minus 2 lambda. So everything is lambda. So we have a linear equation in one variable. We can find the lambda. You expand, simplify things, cancel out if you can, and we get lambda equals 2. Now that we have lambda, of course we can find the coordinates of E. You just replace this lambda here with 2 and you get the coordinates of the E. So replace with 2 and this is what you get, the position factor of E. Now this is just the position factor of E. To find the height, we need to find the length of CE. So CE means E minus C, so it is 3 minus 2, 4 minus 2, minus 1, minus 3, we get the CE. And the magnitude is 1 squared, 2 squared, 2 squared, plus everything and square root everything, we get 3. And for the length AB, yeah, we can just use this 2, 1 minus 2 here, square everything and so on. So we have the length CE, we have the length AB, and the length CD. Yeah, you can find the length CD also from here. 6 squared, 3 squared, 6 squared. So that's what we get. So now we have this trapezium. This side is 3, the parallel side is 9 and 3 then, and we have the height, and we use the area formula for trapezium, sum of parallel sides divided by 2 times height. Alright. Maybe one more question. Express the factor OM and MN. So OM, so from O to M. M is the midpoint, so you can go from O to A, and then from A to D, and then from D to M. That's possible. So here, oh yeah, OM is in the middle between D and F, so this is another way. in the middle between D and F. So